Psychology has a number of parts in terms of ways of looking at behavior. First of all, we looked at things like biology, things like the parts of the brain, the nerve, the neural impulse. So you're looking at biologically what influences your behavior. Then we looked at environment. We looked at learning. How does your environment influence your behavior? Well, people are not just robots. People also think. What does it mean to think? Thinking and cognition. What is that and how does it affect our behavior? Well, definition of cognition is essentially thinking. It's what's going through that brain of yours. What are you ruminating over? And how does that affect your behavior? So, how do we look at that? What is cognition? What is thinking? The first thing is looking at this idea of concepts. A concept is a category of something or an idea. You have a concept of a computer mouse, okay? And where does that concept, that idea come from? Well, you have, the first thing is prototypes. Prototype is sort of your stereotypical example of a computer mouse. This is pretty much a stereotypical example of a computer mouse. A little smaller, but not strange or different or weird. A prototype would be a stereotypical example. You would have a prototype of a dog. If I were to say, think of a dog. A prototype might be a German Shepherd or a Labrador Retriever. Okay? Because that's your picture of a dog when you think of it. Picture of a bird. If I were to say a prototype of a bird, it wouldn't be a penguin. So that's what it means by prototype. It's a sort of the stereotypical. If you think of what are the attributes of a dog? Furry, 4 feet, floppy ears, that kind of thing. That's a prototype. You also have natural versus artificial concepts. Natural concepts are concepts that you find in nature that are kind of, they're grouped together because they just naturally group together. Artificial concepts are things that have been defined by human beings. Things like, what is a circle? Well, we have defined what is a circle. That's not, although circles are formed in nature, we have defined that concept. We've come up with that term. That term is not just a natural term. Then we have, when we're talking about concepts, we have this other thing called schemata. Schemata are an idea about something, like a whole representation in terms of, if you were to think of a college professor, what would you think of? Okay? And it's not just the person, it has what they're wearing, what they look like. If you were to think of a professor's office, they did this study and had people look at a professor's office and then say, what was in there? Well, the majority of people thought there were books, even though there were actually no books in the picture. A schemata is your conception of something surrounding it. You can also have a schemata around going out to a restaurant. You're thinking about going to Wendy's. Your schemata would be, you go in, you walk up to the person that's behind the register, you tell them what you want, you sit there and wait, and they give you your food. It's kind of your scheme, your idea of what happens. That's a schemata. Your conception of what's surrounding something. Okay, so that's kind of the idea of concepts. Then we have what is behind concepts. What's behind concepts is language, how we describe things. Okay? So what are the different parts or components of language? We have phonemes, which are the individual sounds. I say the word mouse. M, a, o, s. It has m, a, o, s. 4 sounds, 4 phonemes. Okay? Morpheme is the individual unit. Mouse. one meaning. Okay? If I say walk, it has one meaning. If I say walked, then it has two meanings. Walk, and I did it in the past. That ed is another morpheme. Morpheme is a unit of meaning. So it can be the root word, and then the suffix or prefix is another morpheme. So we have phonemes, which are the individual units of sound, morphemes, which are the individual units of meaning. We have syntax, which is putting them together. That's like the grammar. It's putting the words together. I use a computer mouse. The syntax would be you have the mouse and then you have me using it. So the syntax would be the way it's put together. Semantics is the social use of language. What's the purpose of what I'm doing here? I'm talking to people about thinking and cognition. The purpose is to explain to college students thinking and cognition. Okay? So semantics are sort of I'm thinking about, okay, who am I talking to? And using language that would make sense to my audience. That's semantics. Those are sort of the pieces of language. How does language develop? Well, you start out by babbling. Little babies are going to play with sounds. Ba, 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 la, 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 ba, ba. They're going to play with sounds. That's the first part. And then around 12 months old, you're going to see first words. You're going to see things like ball, mama, dada, kitty. You're going to see first words. First words are generally nouns, and they're generally things that the infant has a lot of contact with. Mama, dada are very popular ones. Things like ball or binky or bottle. It can be either a person or an object that the child has come in contact with. Again, mama, dada, ball, binky, kitty, key. It doesn't have to be the adult version of the word. They don't have to say perfectly kitty. They don't have to say perfectly ball. Ball for ball. Can be a first word. A first word is when a child says something and you know what it refers to. Mama. They're not saying mommy. They're saying mama. But you know they're staring right at their mother. And you know that's what they mean. That's a first word. So about 1 year old is when you start seeing those first words. And then about 18 months to 2 years is when you typically see a vocabulary explosion. You see lots and lots of added new words. They're learning multiple new words every day. That's typically around 18 months to 24 months is where you see that. And then when people have their 2-year checkup, around 24 months, one of the questions the pediatricians typically ask is, have they put 2 words together? That's when you start seeing what's called telegraphic speech. Not grammatically correct, but it will be things like we go or want up, things like that. More juice. You're going to see 2 to 3 word phrases, and they're going to leave off some of the connector words, but that is typical 2-year-old speech, is that telegraphic speech. When you see a 2-year-old and they're speaking in those 2 to 3 word phrases, that's normal 2-year-old speech. So then you go from that. So you go babbling to first words to telegraphic speech to a preschooler. Think of a 3.5, 4-year-old, and they're speaking in grammatically correct sentences, but they're not very sophisticated. I like juice. That was fun. Those kind of things. You may see some grammatical mistakes. We go to grandma's house. That's what's called an overgeneralization, where they're using the ED. They've learned that concept, and they're using it in an instance where they shouldn't use it. So you have overgeneralization, you have underextensions and overextensions also sometimes. So when you're talking preschool speech, you're talking, for the most part, grammatically correct, but pretty simple, with a few errors here and there. Overgeneralizations and undergeneralizations. You might see a 3-year-old look at a horse and say doggy, because they've overgeneralized all 4-footed animals are dogs. Okay? And you can do the opposite. You can do undergeneralization. You can say a dog is only the dog that they know. So those are some things that happen in language development. There's also this idea of how do kids learn language? In other words, is it nature or nurture? Skinner and the behaviorists thought that children learn language by being reinforced and punished for saying different things. If they say something correctly, they get a good response, so they're more likely to say it again. Good old operant conditioning. So their theory is children is just a really big piece of operant conditioning. Children learn language because they say something, they get reinforced, so they say the same thing again. And that's entirely how language is learned. That's the theory. Well, they look at cases like there was this girl named Jeannie who was found, who was basically not talked to. And they found her when she was 12 or 13 years old. She was basically shut in a room and not given human contact. Severely, severely neglected. They were never able to get her to a normal language development. Now, there were some issues. One of the theories also with her is that she had some cognitive issues to begin with, and then there was the neglect on top of it. In other words, her parents saw this kid with some cognitive issues and said, we don't want to deal with it, and she ended up being severely neglected, which only exacerbated. You see where I'm going with that. So there were some theories as to how well she would have done had she been in a good environment. But she is often used as an example of children need that exposure. And this is true. So that is one of the rationale. That's the rationale behind language being learned through operant conditioning, is that children need that exposure to language in order to learn it. Well, this guy named Chomsky came along and said, hey guys, it's not that simple. Children pick up language too quickly to be just learned through operant conditioning. Children say things that they've never heard. If it was operant conditioning, how can children say things that they've never heard? So he came up with the idea of what's called a language acquisition device. Basically, we as human beings are born ready to learn language. We are born with the ability to learn language. Okay? That's the language acquisition device. In the end, it's a combination of both. We need to be exposed to it, but we're also born with the ability to pick it up really quickly. So in the end, it's both. So nature, nurture, it is both nature and nurture. Another thing with language is this idea of language and thought. Does how you think influence your language, or does your language influence how you think? They've done some studies looking at, there's a couple different things that textbooks bring out a lot. They look at some languages of people who live in extremely cold environments and look at, for instance, they have many different words for snow. Well, the question is, do they have many different words for snow because there's many different kinds of snow, and it's kind of a functional reason? So they're thinking about snow, and therefore their language developed from their thought. Or does the fact that they have many words for snow influence their conception of snow. Another study is they looked at people from a specific culture that had their language did not have number words. Their language had words for one and many, and not explicit words for number. So they looked at, do these people have a conception of number? And what is their conception of number like? In the end, it's that correlation causation thing, and again, it's a little bit of both. It's language influences thought, and thought influences language. What you think about influences the words you use, and the words you use influence how you think about things. So in the end, it's both. That is language. Another aspect to thinking is problem solving. How do we solve problems? Okay. I get in my car and my car won't start. How do I solve that problem? It's a problem, right? I need my car to start because I need it to go somewhere. So how do I solve that problem? How do I solve the problem of my car not starting? First option, trial and error. Okay. I look at a lot of different options. I check my gas gauge. Do I have gas? I check I have one of those push button starts. Do I check and make sure I have my key with me? Okay. Okay. I check and make sure I have oil. I have enough oil. I have enough gas. I have enough. You see where I'm going with this. Check and make sure my battery is. Do I have any power going to my car? Trial and error. I'm checking different things. Let's say I go to my office and I have a bunch of keys on my key ring, but I don't know which key works. How might I solve the problem? Trial and error. Try all the keys until one works. That's trial and error. Another way to solve problems is algorithms. Algorithms are step-by-step procedures. A lot of math has specific algorithms. You have a specific formula that you use to solve a problem. So algorithms in math might be the formula. You're using the formula. You're solving it by using the formula. Algorithms outside of math might be, okay, when my car doesn't start, my dad told me to, step 1, do this, step 2, do this. Or if you're putting together something, you got a new chair from IKEA and you want to put it together. Well, you get out the instruction manual and you follow the steps in the instruction manual. That's an algorithm. Following a recipe is an algorithm. So you have trial and error, you have algorithms, which are like recipes, which are like instruction manuals, which are like mathematical formulas, are specific ways to solve the problem. Then you have heuristics, which are rules of thumb. A rule of thumb for seeing if your car doesn't start. Well, your dad told you to first check X. That would be a rule of thumb. Okay, that would be a heuristic. Okay, a heuristic, another heuristic might be working backwards, working forwards, hill climbing. There's a lot of different things. You look at, what is your ultimate goal? My ultimate goal is to get my car started. So a heuristic might be going through all the different pieces. Well, it needs to get power, gas needs to get there, all the different pieces of the car getting started. And looking through each of those different pieces to see where in the step something goes wrong. That might be if you're looking at heuristics, you're looking at, again, things like means end, things like hill climbing, things like what is your ultimate goal and how do you get to it. Those are heuristics. Okay, so what are some pitfalls when it comes to problem solving? Two big ones are mental set and functional fixedness. Mental set is, I've always solved this way in the past, so I'm going to solve it this way in the future. It's you've always used a certain strategy and you're going to stick with the strategy you've always used. That is mental set. Okay? My car doesn't start, it's because there's no gas. That's what I always look at. That's what I'm going to look at. That's what I'm going to assume is wrong with it. Mental set. It's like you always, okay, this is the formula I always use to solve the math problem. That's mental set. Functional fixedness is having the problem of only seeing a certain function for an object. The classic is you have a sock and you can only see using it as a sock. You can't see using it as a rag to clean something with. Or you have a key and you see it as opening a lock and you can't see it as prying open the top of a bottle. Okay? So functional fixedness would be only seeing one use of an object and not being creative and seeing multiple uses. Those are some common pitfalls. We also have some biases. We have an anchoring bias. If you are told something and you are given an approximate, if you are given an approximate of how many or how much, that's going to be in your mind and it's going to be anchored and you're going to be thinking about that. That's kind of the anchoring bias. People do that in advertising a lot. When you go to a store, you have something where they put a regular price and then they discount it because they want to anchor it and they want to make you think that it's worth more than it is. Okay? So that's what the anchoring bias is. We have confirmation bias, which is you only look at things that confirm your original thoughts. You only look at, you believe something and you're not looking at all the evidence. You're only looking at evidence that supports your original idea. That's confirmation bias. Then we look at hindsight bias. Hindsight bias is when we've made a decision, we're looking at stuff that supports the decision that we've made. Okay? That's hindsight. Hindsight is 20/20. In other words, we made a decision or we solved a problem and, oh, I knew that all along. Representative bias is when we're trying to make a decision or solve a problem and we use the stuff that immediately comes to mind. The classic and representative bias is thinking that airplanes are less safe than cars because when there's an airplane accident, it's publicized and we think about it. That's what's available to us. Or representative. That's the availability heuristic. And that has to do with the representative bias too. Okay. So, what do we have here? We have problem solving. We have concepts. Okay. And that's a piece of when we talk about cognition and intelligence.